Thanks so much, Lauren. And of course, thanks to all the folks at IDEA for making this webcast possible. It is an excerpt from a white paper that I wrote for IDEA, so I hope you get a copy of that. It has much more detail in it than I can cover in this short webcast, so do take a look at that. We're going to be talking about a number of things. The first one is the concept of a data fabric, and then I'm going to give you an example of an architecture that is an example of the data fabric itself. Then we're going to go into a bit more detail. We'll talk about the data fabric processes, implementing the data fabric, and then some things to think about. Let's take a pause, though. It's been a tough year. 2020 started out with such hope. So much, I thought that year was going to be terrific, and boy, it changed in a heartbeat, didn't it? Many things changed. Our economy did, our world did. We're now working virtually. I'm talking to you from this wonderful blank void over here instead of in person. So a lot of things have changed, and that's one of the reasons why I wanted to talk about the data fabric. And I do thank IDEA for suggesting the title. I think it's a terrific one. It's been a time of reflection. It's been a time of difficulty. Many of us are working virtually, and we had to make, really quick changes in our home offices so that we could communicate with each other. We could get our work done. We made changes to our personal lives. Kids were no longer in school. We're wearing masks as much as we can and social distancing. Fortunately, much of that is going away. Thank you. Thank you, vaccines. Much of that is disappearing as fast as it can, and that's a good thing. I hope we remember, though, the reflections that we made. So let's start on this webcast because a lot of it is going to be about those reflections. First of all, 2020, if it taught us anything, change happens. We've always been saying that, but boy, can change happen. And it happens in a heartbeat, suddenly, unexpectedly, and with huge impacts on our personal lives, on our companies, on our world, on our environment. It also taught us that our enterprises have to be agile. We had to change on a dime, didn't we? We had to be able to change our entire set of objectives and goals, along with the supporting operating processes, decision-making capabilities, almost overnight, almost immediately. For decision-making specifically, agility. Agility became the catchphrase, didn't it? Agility comes from the ability of the business users to find and use that analytical data so desperately needed during the pandemic, and to find the analytical assets for everyday decision-making as fast as we can. Where's my market going? Where are my customers going? Are my products moving? How do I sell them without a physical store anymore? And so on and on it went. Unfettered access to the analytical data. It comes in the shape of a data fabric, and that's what we're going to be drilling into in great detail over the next hour. The data fabric is a new term for a very old idea. Not that new, folks. It's certainly a new term. An all-encompassing analytics architecture that is easily understood, easily accessed, easily implemented and maintained, and makes sure that all of the analytical data that we have can flow easily throughout the enterprise. Much like in your home, electricity flows from room to room to room. There is no difference. I can access it anywhere in my home. That's what we want with our data. That's what we need with our data. All right, what are the benefits then of a data fabric? Well, certainly easier data management, better security, much more reliable, and of course, that all-important consistency. The second thing is democratization of data, making it available for everyone, anyone with a need. And of course, access to the analytical assets that are derived from that data. Easy discovery, easy navigation. Oh my goodness, how hard it's been in the past to even find the data, much less navigate it. And of course, find those assets by all users from some kind of centralized access mechanism. And we're going to talk about that during the architecture phase. The other one is the reduction in complexity, promoting automation. Automation is the key to reducing complexity, streamlining processes that create and maintain the environment. So key to making it less complex, easier to maintain. And then, of course, a coordinated, there's a word, a coordinated documented process of data lineage and usage. Where did it come from? What did we do with it? What happened to it on its journey from its source to its ultimate target or analytic asset? The analytical assets that use that data, who uses it, and what assets are available to them for a better managed environment. Now, the one thing that a coordinated documented process of lineage and usage can give us too is it can put a bright spotlight on data redundancy, on inaccurate data, senescence, data that's old and no longer should be used, potential security or privacy breaches. These can be better controlled than in a totally chaotic, undocumented situation. And then, of course, the last one is so critical. A controlled environment also promotes better governance. Better governance. Are we doing the right things with our data? Are the right people getting to the right data? And so on and so on. We'll talk about data governance throughout as well. Alrighty, so that's the first part, the introduction to the concept of a data fabric. Now let's talk about an example. And this is an example of an architecture that I developed in conjunction with Colin White, my good friend, a few years back. And we did it because things were changing so rapidly in the analytics world. It used to be we had a data warehouse and maybe we had some data marts and gee, everything was hunky-dory keen. Then all of a sudden we started hearing about data lakes and exploration and data science, all kinds of new terms that a data warehouse just didn't seem quite right for. We heard about big data. Oh my goodness, what are we going to do with big data? We also started hearing about weird kinds of data, social media data, Internet of Things data. So the old architecture of just the data warehouse and data marts was kind of falling apart at the seams, trying to accommodate things that it was never meant to accommodate. That's where this new architecture was developed from. I call it the extended analytics architecture, an example of a data fabric. We're going to walk through it. So I'm not going to go through it in great detail here on this slide. We're going to go through it page by page in detail. But I want you to notice that, yes, first of all, a traditional enterprise data warehouse is still there. It's on the left-hand side, bigger in Dallas. There it is. But there are a lot of new things in this architecture that perhaps you've never heard about or have seen in your own architecture. So let's start walking the architecture from the bottom up. First of all, operational analytics. The operational environment has certainly not stood still. For example, we now have embedded or callable BI services, traditionally from our data warehouse, right? I'm in the middle of an operational process. I then have to call some kind of BI service so I can detect real-time fraud, for example, or I can optimize online promotions or location-based offers. They take a lot of coordination within the operational system itself. We also have a real-time analysis engine, and this may be something that is new to a lot of people. Real-time analysis, that means real-time analysis on real-time data, data as it's streaming into the organization. That's a whole different ballgame. For example, traffic flow optimization or web event analysis, risk analysis, stock trading analysis. The idea behind the streaming or the real-time analysis in, let me try that again. The whole thing about the real-time analysis engine is that it can correlate unrelated data streams like weather effects on product sales. Let's move on up the architecture to the data provisioning use case. In this case, data integration. That's on the left-hand side. It's the first step out of the operational systems, if you will. This is the heavy lifting process of extracting and transforming to a standard format and then loading predominantly structured data, mostly in batch and mostly into our EDW. This is where we physically consolidate data into the trusted EDW sets for analysis. We invoke data quality processing where needed. We use low-cost hardware now and software that enables large volumes of data to be combined and stored. And because it is trusted data, it's going to require a more formal data governance policy. Policies that manage, I am so sorry, Donna. Policies that manage our data security, our privacy, our quality, even archiving and ultimately the destruction of the data. Yes, we do occasionally destroy data in our data warehouses. On the other side, perhaps something new to you, something that we named a data refinery. A lot of people call it data wrangling or data prep, but basically it's ingesting the raw, detailed, structured and unstructured data in batch or in real time into a managed store. And that store is what we're going to talk about soon, the investigative computing platform. It distills the information into useful business information and distributes the results to those downstream systems. It may also directly analyze certain types of data. But again, we're talking about low-cost hardware and software, enabling large amounts, this is where the big data stuff comes in, of detailed data to be managed cost-effectively. Now, unlike the data integration platform where we are producing trusted data, this data is not quite as trustworthy. It's for experimental purposes, explorations. So it requires a more flexible governance policy to manage the security, privacy, quality, archiving, and ultimately the destruction of that data as well. Next up, the EDW. Yeah, it didn't go away. It's still there. It still has a purpose. Its purpose, though, is more clarified, is more clear. It cannot do all things for all people, but it can do some things very, very well. It is the production analysis repository, production analytics, things that we have to trust, things like key performance indicators or customer analysis, the next best offer for them, a lifetime value score, profitability analysis. We can't guess at this. We have to know it. We have to trust the data behind it. And that's what the EDW is really good at. Every Monday morning, it's going to create a set of trusted reports or analyses. Every month end, it's going to create a dashboard or reports, or again, all kinds of advanced analytics with trusted data. If we look at the other side, though, go up the other side, we now bring in something that's new, an investigative computing platform. This is where a lot of the newer technologies came into to being here, like Hadoop, in-memory computing, columnar storage, data compression appliances, and so forth. The goal of the investigative computing platform was to solve the problem of exploration, experimentation, data mining, predictive modeling, all that kind of stuff, cause and effect analysis. Basically, what this environment could do that the data warehouse could not do were general, unplanned investigations of data. The data warehouse is planned. We have a known set of queries and analyses that we run against the data warehouse. In this environment, everything goes, anything goes. We can investigate, we can explore, we can twist and turn, we can experiment. So the investigative computing platform, or data lake, if you want to call it that, certainly is a valuable and very important part of our analytics environment. The next one are the analytical tools and applications, and there is just an explosion of tools and types of analytics and applications do: creating reports, performing analyses, creating dashboards, displaying the results, visualizing those results. These are the tools that increase the productivity of the analysts and the data scientists greatly. Now, there are one other piece of it. There is one other part of the extended analytics architecture, and that's the other sources of data. That's all that new stuff. The sources of data that are not in the normal streams, coming directly out of the operational systems and so on. Normal streams for this architecture, things like purchase data, Internet of Things data, social media data, whatever it is, that structured and sometimes variably structured data that maybe we want to bring into our analytics environment because it adds so much to the actual analytic environment itself. My next to last slide is going to talk about the data flows. I've given you the different components in there. They are all in front of you. The operational systems and so forth and so on, the EDW, the investigative computing platform. What you didn't see in the architecture, though, are the flows of data between these components. For example, from the operational systems to the traditional EDW, going through our ETL or data integration technologies. The green flows here are the physical movements of data. We physically move data from our operational environment into our EDW, into our investigative computing platform, and even into our real-time analysis engines. We then move that data into our analytical tools and the applications there. So the green arrows are all the physical movements of data, physical flows. What's becoming even more critical these days is what goes on in the blue, if you will. The blue is virtualization, data virtualization. The ability to bring together data in ways that we never could have before is critical in a data fabric. We don't want to have to physically move every piece of data, so why not virtualize it? Let's move it in easier fashion. Bring it together virtually and then let it go. We didn't physically move it. Very important, and we'll talk about that as well. Last slide on the architecture. All of this looks great, but it needs one thing more, and that's an access point. How do the business analysts, the data scientists, even the people implementing and maintaining this environment, what's their access point? How do they figure out what data is there? What components should they be using? What analytic assets have already been created? That's where a data catalog comes in. It's our entry point, our storefront, if you will. It consists of a business glossary, a data dictionary, data lineage, a lot of the utilization statistics. And of course, it exposes all of the data and assets that are available, even if you don't have the proper access to get to them yet. I'll talk more about the data catalog in just a moment, but it's critically important that we understand that it is the storefront. We also have to believe that the data catalog is also where a lot of the governance comes from. The business glossary contains the rules to entitlement and access to data. The glossary contains those standard definitions that we all want. What's this KPI mean? What is it made of? How is it calculated, and so forth? All right, let's move to the processes. And there's a whole bunch behind these processes here. So let's just talk about them in more detail. Once we have a solid foundation, once we have a great architecture, we now can point our attention more to the processes that bring that architecture to life. And there are two sets of them: business processes and technical processes. So let's get into them in more detail. The business processes, this is a very simple view of the business processes, but they start with discovery. The data catalog, again, that storefront, if you will, easy to use entry point, where business users can quickly find the data that they want, quickly find the analytic assets that they're looking for in unambiguous, non-technical language. English, in other words, relevant to the business, and so forth. The catalog supplies a browsable ontology that gives the context, not just the content, but the context of all the data and the assets. It should include the meaning of the business rules, the explanations of security and privacy, and of course, it should act as a recommendation engine as well. Oh, you're looking at this. Well, here are some other reports or analytic assets in that same vein. Maybe you might be interested in these. And of course, it's also where that person, the business user, would go to find who do they have to talk to get permission, governance, permission to access that information. Now, next in the process is a fork. Is the data or analytic asset available, or is it not? If it is available, then the business user can quickly access it, or at least figure out how to get access to it, submitting a request, for example, for permission to access that particular piece of data. If the data is or the asset is available, then they can determine if they already have permission to access it. On the other hand, if the data is not available, they have good evidence that it's not available, and they can present that to the technical team and submit a request or whatever the process is in your organization to get the ball rolling on creating that data. The next step is to analyze. If they have the data and they have access to it, now they perform the step of analyzing. And of course, there's a lot that goes on there, of course. Informal informational making capacity there. The business user can create their own analytical asset. They can tweak an existing one if it's parameterized. They can say, I only want to look at these particular parameters and so forth. Anything that they can do to fit their specific needs. And again, they have to make sure if they do change something there or create a new analytic asset, then their responsibility is to make sure that is registered as well in the catalog so that somebody else can find it. And then finally, back to iterate. We go back to discover if we have to. Once they've completed their analysis, their attention may turn to a completely different area of data and analyses, and the process starts all over again. But with the catalog, they can find what's available and go on from there. Perfect. It works like a charm. The next set of processes are the technical ones. You'll notice that it looks very similar to what's going on in the business processes, but there are some not so subtle differences. For example, discover. For a technical person, they start with that same storefront, that same entry point, and they use Discover to find out what data and analytical assets already exist. If they got a request, the first thing they want to look for is, does it already exist? Just checking. Or can I easily create the asset because the data does exist and I don't have to go back to the beginning and bring the data in from the very get-go. They get the full lineage, the full metadata, if you will, on data lineage and on usage statistics and impact analysis. If they're changing something at the front end of this architecture, have they done something to screw up the back end, somebody's report or somebody's dashboard? With that full lineage, they can see what they're doing and whether it's impacting further things downstream. Again, they have the choice of the data is not available or the data is available. I've already explained the available. They move right along and say, okay, things are going well. If it's not available, then they start the whole process here. They begin their research to figure out which of the sources would be the best source for the data. They invoke their ETL or ELT technologies there. They begin to assess the quality of the data and so forth. And they must document all of that information so that it can then go back into that data catalog. Now, an important part of this data not available piece is to have the right technologies. And that gets into the analyze, the need step. Once you've identified the source, you then determine which of the three components, the enterprise data warehouse, the investigative computing platform, or the real-time analysis engine will be used. Once you get that, you then start the analytical processes that will be used on it and the business community who will be using it. You gather all of that information up, and then they begin to identify which component should the environment house this data. Now, the design and deploy we've been doing for quite a while, of course. Based on that analysis, you then begin to invoke if you're going into an EDW, you invoke your data integration technology. This is where automation really, really makes a difference. If you're going into the investigative computing platform, then you're going to invoke the data prep or the data refinery type technologies. Again, very critical that it has the right metadata, that you capture that so you can get it back into the catalog. The streaming analytics is a whole different ballgame, if you will. The idea here is that the data is first analyzed and then stored. Very different from the previous two things. In the EDW or the ICP, we store the data and then we analyze it, not for streaming. So it's a whole different set of technologies. Learn about them, read about them. You're probably going to have to bring them in at some point. And then finally, monitoring, so key to everything. Making sure that the data catalog has been updated, that the changes made to the data fabric, the personnel must also be continuously monitored for their usage of the data. Are they heavily using some and not using others? You know, what's the usage statistics look like? And of course, the impact analysis. So all of those additions improve the discover process. Returning back to discover, we go back to the beginning again, now with a refreshed data catalog, and life is good. All right, let's talk about the implementation now of the fabric. I'm going to go through this rather quickly, but I do encourage you to get a hold of the white paper. Do make sure you get a copy of it. There's so much more information there than I can talk about here. But let's talk about the technological support. First of all, the data catalog, that storefront. All the technical metadata, the business glossary, the dictionary, the governance, and so forth and so on. The data is generated by other technologies like data modeling, data integration, data prep tools, but it's consolidated in that data catalog. It's put into the data catalog for its ease of use, easy to understand and get information from. The data catalogs, though, can perform certain analyses themselves, like the data lineage. Now that they've got this entire set of metadata, they can analyze where it came from, what happened to it, where it went to, and they can also look at the impact analysis. If I change this, what have I affected downstream? They can also start to help you with sensitive data by detecting it, presenting recommendations to the business users as well. Data modeling, each repository in the architecture has to have a schematic. It has to have a schema. And the different levels from logical to physical models. They're used in designing the EDW and the ICP, the Investigative Computing Platform in particular. Data models of the operational systems are used in the data integration and data prep technologies. Data modeling is also a huge supplier of information that we find in the catalog, definitions, for example, changes to the database design, the existence of the data itself and its location, all kinds of glossary items that we find in our data modeling technologies. And of course, the data models have to be connected to the business glossary itself. That's what makes a well-managed data catalog. Data integration, good old ETL or ELT, whichever flavor you choose. Key factor here. The best practice, as I mentioned, is to automate as much of this process as you can, as much as you can, from curation to design and everything else in between. Documentation is not a last-minute thing. It's mandatory. We have to have the documentation of all of the data integration steps. so that we can put that into our data catalog and understand exactly what's going on with the data. Data prep, the creation of a data lake or the investigative computing platform, whichever term you use. Data prep extracts from the sources, it reformats things and lightly integrates it, but it reformats it to make it available for analysis, for that exploration and experimentation. The investigative computing platform, as I mentioned, is meant for those unplanned general queries, usually done by data scientists. And again, the data prep tool should be as automated as possible too, should automate that process and produce the very much needed documentation about what we did to the data. Next up, data virtualization. As I mentioned in the data flows, it's becoming a critical component. The ability to bring data together virtually rather than physically. Access to all of the data, regardless of its location in the data fabric, could be on premises, could be in multiple clouds, don't know. But access is a major step toward data democratization, making the data available. Popular virtualization data can be cached in memory. If it's used very often, then we want to make sure the performance is top-notch. We may cache it in memory. We may store it somewhere temporarily for a while or whatever. Virtualization can also be used to prototype. It's an easy way to spin something up quickly, take a look at it, and then if you have to physically create it, you've pretty much got a model of what it should look like. Data analysis and visualization, key technologies, of course. The analytical capabilities range from simple reports and dashboards to very complex and artistic, if you will, data visualizations, all the way to predictive and other very advanced analyses that our data scientists are performing. No single technology in this category, I hate to break it to you, can satisfy all of the business community's needs. So most likely you will have multiple tools, at least one in each of these categories that I just mentioned. Monitoring, yep. Usage statistics, the ability to monitor what data is being used and by whom gives the technical personnel a great insight into the overall performance. It also helps them figure out what data has to be right there in front of the user, what data can maybe be on cooler storage mechanisms. Is some of the data seasonal? Are there spikes in utilization that the technology people should be aware of? Should it be, data commonly used should be somehow cached or virtually brought together beforehand so that we get good performance. And then, of course, good old data storage, rounding it out. In the past, we had to separate the data warehouse from the investigative computing platform, the investigation environment, because the analytical techniques were basically incompatible. The good news with the separation of data storage from compute power, we are now seeing situations where the data warehouse and the investigative computing platform can actually reside in the same storage technology. That helps, believe me. And then last, the real-time analysis area. Major difference is that the data is analyzed before it's stored, as I mentioned. The technology has to bring together multiple streams of data that are analyzed in a real-time mode, real-time, on real-time data. And it is a relatively new area, but hopefully it's a welcomed addition to any data fabric that you're creating. All right, last couple of slides. Please do, by the way, before I forget, please do enter your questions because we will have a Q&A at the end. So do that and do fill out the surveys as well. You'll figure out why. It's a good thing for you to do. So let me talk about things to think about here. No single technology or technology company has a complete set of capabilities that I've listed in the paper and in this webcast. Some come very close to having it all. Believe me, Idera is one of those companies. But it's important to understand where there may be gaps, some things that maybe are not in their technology stack, and holes in the offering. If that is the case, and everyone will have that, every technology company will have some gaps, then partnerships become critical, and they are much more than just a single handshake or a dinner somewhere. They have to have a deep understanding of each company's offerings and how the interfaces have to come together seamlessly between the technologies. For an architecture to work, the enterprise has to stand solidly behind it. That means executives must step in. They must support the architecture, especially when rogue attempts are made. Sometimes we have to build some kind of a workaround, but once that workaround is no longer needed, then it needs to go away, and the executives have to enforce that. The business community interfaces are simple. They're easy to understand. That's one of the keys. We want to make it as simple as we possibly can. Unfortunately, the more simple we make the front end, it means the back end gets far more complicated for the technical people. The value of the data fabric depends on the robustness of the information found in that data catalog. Out of date, stale, inaccurate metadata, boy, immediately leads the users to distrust the data, not use it, go off on their own, find their own data that they do trust. And then finally, simply forklifting a legacy analytic component. Many of you are thinking, well, I'll just throw my data warehouse into the cloud and it'll perform so much better. Yeah, you can do that. You can throw it into a fabric environment. That may be something that you have to do for expediency, but please, know what you're doing there. It can cause some real problems. And it's also a wonderful time for these legacy components to be reviewed, refreshed, redesigned, made more streamlined, get rid of the stuff that is redundant, no longer used, and so forth. And like I said, many technologies claim they can do it all. Very few, if any, can. So pick a vendor that meets the most of your technological needs and make sure they have a strong partnership with others to complete the entire architecture. All right, so with that, again, I encourage you to enter your questions. I'll be happy to answer them at the end of this webcast. My thanks again to Idera, and now I'll turn it back over to Idera for the rest of the webcast.